1. Definition of a lifter. A lifter is a common ejection mechanism in injection molds, primarily used to address demolding challenges caused by undercuts in plastic parts. It operates through an angled movement, typically driven by an angle pin or guide rail during mold opening, allowing the part to be released smoothly without sticking or damage. 2. Functions of lifters. 1. Resolving undercut, demolding issues. When a plastic part has internal recesses, side holes, or snap fit features, standard ejector pins cannot release it directly. Lifters provide lateral movement to clear the undercut, enabling successful ejection, to simplifying mold structure and reducing costs. Compared to sliders or hydraulic pour pulls, lifters have a simpler design, making them cost-effective for small to moderately complex undercuts. 3. Improving production efficiency. Lifter movement is automatically controlled by mold opening, closing, eliminating the need for external power sources, for example, hydraulics or pneumatics, making them ideal for high-speed injection molding. For enhancing product aesthetics, lifters are usually placed on non-cosmetic surfaces, for example, inner sides or bottoms, to avoid visible parting lines or ejection marks. 3. Working principle of lifters. Lifter movement relies on mold opening, following this typical process. 1. Mold closing. The lifter remains stationary during injection to ensure proper part formation. 2. Mold opening. As the mold opens, the lifter is pushed by the ejector plate while being guided by an angle pin or rail, forcing it to move at an angle. 3. Ejection completion. The lifter slides at a predetermined angle, usually 5 to 25, to clear the undercut, followed by full pot ejection via ejector pins. 4. Common types of lifters. E. Standard lifter, driven by an angle pin, suitable for simple undercuts. 2. Delayed lifter, remains stationary initially, then moves at an angle later, ideal for complex undercuts or multi-stage ejection. 3. Hydraulic lifter, powered by a hydraulic cylinder, used for long strokes or high-precision applications, less common, often replaced by sliders. 4. Two-stage lifter, uses dual-motion lateral shift followed by ejection for deep cavities or special geometries. 5. Key design considerations for lifters. 1. Angle selection. The lifter angle, typically 5 to 25, must balance ease of ejection with wear resistance. Too shallow an angle may cause sticking. Too steep may lead to jamming. 2. Material and heat treatment. Lifters are often made of hardened steel, for example, SKD 61, H13, and heat-treated HRC 48 and 52 for durability. 3. Lubrication and guidance, where plates or oil grooves reduce friction and extend lifter lifespan. For stroke calculation, the ejection stroke must exceed the undercut depth to ensure complete release. 6. Conclusion. Lifters are essential in mold design, particularly for plastic parts with undercuts. Their simplicity, cost efficiency, and reliability make them widely used in electronics, appliances, automotive components, and more. Proper design of angles, materials, and motion ensures longer mold life